Hi, welcome back. It's the discussion for 2.2, which is applications of linear inequalities. So the story problems. It was kind of a short homework, so we'll do a couple of the problems that were asked. Let's start with number 4. So Jill is renting a car while hers is in the shop, and the rental company charges $32 plus 24 cents per mile. Okay. If she can spend a maximum of $110 on the rental, how many miles can she drive? Alright, so the idea here is that the amount that she's going to spend, the total amount, has to be less than or equal to, because she can spend 110, but she doesn't have to go all the way up there, so it's less than or equal to this $110, right? And it's the amount right here that we have to create some mathematical expression for. What is that expression? Well, that amount is $32 right from the get-go, plus 24 cents per mile, so 0.24 times x, where x is the number of miles that she can drive. This expression needs to be less than or equal to 110, and that's it. That's the hard part of this problem. Unless you hate decimals, then that's the hard part, but we've created our equation, right? I'll solve it by subtracting 32 from both sides. So I've got 0.24x less than or equal to 78. Divide each side by 0.24, leaving me with x on the left. I divided by a positive, so I don't have to do anything to this. Is that too low? It's almost too low. So that leaves me with x is less than or equal to, and here of course I divide by 0.24 on this side, and I want to say that's 300. But I need to cheat, so I will here. 325. So she can drive up to 325 miles, and then if she goes beyond that, she'll go over $110. All right, let's look at number 6. Six says, Jake is buying a car. In addition to the price tag of the car, he must pay a $260 license fee. And a 5% sales tax. Okay. If he wants to spend less than $20,000, what is the price of the car? What price of car can Jake buy? So we can set up another inequality here. The idea is that this would be like kind of the same deal. The amount that he spends needs to be less than or equal to, well, technically, because it does say less than, we're going to take that equals out of there, right? Okay. But then the question actually below says at most, right? So it's not particularly strong wording. If it asks less than, we're talking about strictly less than. But then the question turns around and says the at most. So at most is a less than or equal to, right? So Maybe not the best wording in that problem, but it doesn't matter. We're gonna end up solving for x, and that number on the right-hand side is the number that he would wanna stay under, okay? The amount that he spends then should be less than or equal to, or whatever the case may be, 20,000. Right? The amount that he spends is these two things, but there's one more thing that I haven't written, and that is the price of the car itself. So I'll write that up here. Maybe let's just call it X is the price of the car. Well, it's these three things, so let's write that in our expression. The amount that he spends on this car is the amount of the car, plus a $260 licensing fee, but plus he has a 5% sales tax, and so that is 0.05, that's 5%, multiplied by the price of the car. So the price of the car is going to appear twice in this inequality. This must be less than or equal to 20,000. And that's my inequality that I'm playing with. So I can combine these. This is 1x plus 0.05x. I'm going to end up with 1.05x. Plus that 260 needs to be less than or equal to 20,000. Right? Subtract off the 260 to get it to the other side. That leaves me with 1.05x, and not a lot of room on my board, is less than or equal to 19,740. Okay. And I'm going to move this up a little bit. Well, let's run with it. Divide each side by 1.05. 1.05, yoink. I'll just put my result over here. X is then less than or equal to, that's not happening in my head, 19,740 divided by 1.05, it's 18,800. Did that make it on the screen? Yes. So there we are. So the most he can spend, $18,800. When all the other junk gets tacked on, walk out the door, spending $20,000. Good. All right, thanks, and I'll see you next time for 2.3.